You know that little blinking box, probably tucked away behind your TV or on your desk? The one with all the cables plugged into it? Well, that thing is basically the unsung hero of your entire network. It's the reason all your gadgets can actually talk to each other. And today, we're going to pull back the curtain and figure out what a network switch actually does. I mean, really, ever stop and wonder how that even works? How does your computer know exactly where to send that document you want to print? Or how can you be streaming a 4K movie while someone else in the house is in an intense online game? And, nothing crashes. It all seems so seamless, right? Well, the answer is that little box, our hero device. And at its heart, that's what a switch is. It's not just some dumb splitter. A much better way to think of it is like an incredibly smart traffic cop for all your digital stuff. Its entire job is to look at every single piece of data and make sure it gets exactly where it needs to go, super fast and without causing a huge traffic jam. Okay, so let's dive into our first section here, the smart meeting point. To really get what makes a switch so special, we gotta look at the job it was actually built to do. All right, so switch is basically the heart of your local area network, your LAN. It's the thing that takes all your wired devices, your PC, your PlayStation, your smart TV, you name it, and connects them all to this one central spot. It creates this private little digital universe where they can all chat with each other directly. But, and this is the fun part, to really appreciate how brilliant this is, we have to look back at the old, really clumsy way we used to connect things. So let's take a little trip back in time. Because to really get why switches are so amazing, you have to understand the old, noisy way of doing things. We're talking about the problem with hubs. See, before we had these sleek, smart switches, we had let's call it their simpler, much louder ancestor. So yeah, meet the hub. Now, on the outside, it looks pretty much just like a switch, right? Just a box with a bunch of ports for your cables. But what was going on inside? Well, that was a whole different story. It worked on a completely different and, honestly, a totally chaotic principle. And here is the absolute key difference. A hub was like someone standing in the middle of a crowded room and just shouting everything. Anytime it got a piece of data, it didn't know what to do with it, so it just blasted it out to every single device on the network. A switch, though, it's like a postal worker, carefully and quietly delivering a letter only to the right mailbox. See the difference? One's a screamer, the other's a professional. And you can probably guess what happened next, right? That whole shouting method caused a ton of problems. You had data packets just constantly crashing into each other. They're literally called collisions. It created this massive digital traffic jam that slowed the whole network down to a crawl. And the more devices you added, it got so much worse. It was inefficient, it wasn't secure, it was just a mess. There had to be a better way. And of course, there was a better way. And that brings us to the really cool part, how a switch actually thinks. This is its superpower. It doesn't just blindly blast data everywhere. Nope, it makes intelligent decisions. And it does all this using one very specific piece of information. And that key piece of information is called a MAC address. The easiest way to think about it is like a permanent, unchangeable fingerprint for your device's network connection. Every single network device in the world has one, and it's totally unique. And this is the secret sauce. This is how the switch can tell all of your different devices apart. Now, for those of you who like the technical details, this all happens at what's called Layer 2 of the OSI model, the data link layer. All you really need to know is that at this level, data gets bundled up into packages called frames. And the important part is that every single one of these frames has two addresses stamped on it, the MAC address of who sent it and the MAC address of who it's supposed to go to. And the process the switch uses is it's so simple, but it's incredibly effective. Every time a data frame shows up at one of its ports, it just follows this same three-step logic over and over again. Learn, decide, and deliver. That's it. So picture this. When you first plug in a brand new switch, its brain is totally empty. It has this little memory bank inside called a MAC address table, but right at the beginning, it's a blank slate. It has no idea what devices are plugged into it. It's just sitting there, ready to learn. Okay, so let's walk through it. Let's say your laptop is plugged into port 1, and it sends out its very first piece of data. The switch sees this and immediately springs into action. It looks at the sender's MAC address on that data frame and basically says to itself, aha, okay, so the device with this unique fingerprint is plugged into port 1. And then boom, it jots that down in its table. And just like that, you can see the learning process in action. The MAC table now has its very first entry. The switch has started to build its own internal map of your network. And it just keeps doing this for every single device, every time they send something out. It's constantly learning and updating that map. Okay, so step 2, decide. Now the switch looks at the destination MAC address on that frame. It quickly checks its new map. Do I know where this is going? If the answer is yes, if that address is in its table, it makes the smart move and sends the data only to that one specific port. Now, what if it doesn't know? Well, for the first time only, it'll do what a hub does and send it everywhere. But as soon as that destination device replies, the switch learns where it is, and it never has to shout again for that device. And finally, step 3, deliver. The switch sends the data packet down the correct, private pathway, and it arrives exactly where it was supposed to without bothering a single other device on the network. And the most amazing part? This whole learn, decide, deliver process happens in a tiny fraction of a second for millions and millions of data packets. So, all these technical details, why should you care? What's the big picture here? Well, it might seem like we're in the weeds, but the impact of this simple process on our daily lives is, well, it's absolutely massive. This smart, simple thinking is literally what makes our modern digital world possible. I mean, that's really the bottom line, isn't it? By getting rid of that chaotic shouting that hubs used to do, and instead creating these private, one-to-one conversations between devices, switches are what gave us the fast, stable, and reliable networks that we just completely take for granted today. This is the magic that's happening behind the curtain. It's the real reason you can stream that movie while someone else is gaming, while a document is printing, all at the same time, without the whole network just grinding to a halt. The switch is in the background, silently managing all those different conversations, giving each one its own private lane. It's the quiet hero that just makes everything work. So there you have it. The switch is this brilliant little device that builds a map of your network so it can direct traffic perfectly. But that brings up a really interesting question, doesn't it? How does it remember it all? I mean, what happens when you unplug your laptop and move to another room? How does the map get updated so it doesn't get old and out of date? Well, that's a great question for another time.